In this video, we will present the steps required to select the equipment grounding conductor using the Sizer electric software. Section 250.118 of the NEC, or the Mexican Official Standard NOM 001 Std 2012, hereinafter referred to simply as the code, states that the equipment grounding conductor may be made of copper, aluminum, or copper-clad aluminum, whether bare or insulated. However, it also permits one or a combination of different types of conduit, cable trays, armored cables, wireways, cable bus structures, and other metallic raceways. For this reason, although grounding protection is required by the code, the selection of an equipment grounding conductor is optional, since the installation may use a conductor or other permitted means to protect users. It is also important to note that, in the case of medium voltage conductors, the strategy to protect personnel may be based on protective relays or other methods. As can be observed, there are several protection strategies in addition to the equipment grounding conductor, which is why the calculation of this conductor is optional when defining the conductors of a circuit. If the user decides to achieve protection by means of a solid equipment grounding conductor, the software can assist with this task. The requirements for selecting the size of an equipment grounding conductor are defined in Section 250.122a, which specifies that these conductors shall not be smaller than those shown in Table 250.122. This table establishes a relationship between the rating or setting of the circuit overcurrent protective device and the appropriate grounding conductor size, considering the conductor material, copper, aluminum, or copper-clad aluminum. Let us see how to perform this selection. When the option Estimate Equipment Grounding Conductor is enabled, a window opens to enter the protective device data. In this window, the first field defines the type of protection, the second field defines the frame, and the third field defines the setting. If a fuse is selected as the protection type, the fields change to fuse holder and fuse, in order to define its ampere rating. If a relay is selected as the protection type, the fields change to maximum protection value and setting, corresponding to the value configured in the relay to protect the equipment. If none of the options displayed in the protection type field describes the device used to protect the circuit, the option Automatic Overcurrent Device may be selected, which serves as a generic reference for any protection device. Although this window requests the second field, frame, fuse holder, or maximum setting, this value is used only to complement and populate the conductor schedule report. In practice, it is the third field, identified as setting or fuse, that is used to select the initial equipment grounding conductor size, in accordance with Table 250.122. It is important to clarify that the rating or setting of the equipment protective device shall be selected in accordance with the requirements of Section 240 of the Code. As is well known, proper selection of the device rating or setting depends on several factors, including the operating curves of the protective device, the equipment damage curves, conductor ampacity, and protection coordination practices with other system elements located both downstream and upstream of the protective device. The procedure for properly selecting the protective device rating or setting is beyond the scope of the software. The application provides only a basic suggestion of a possible device rating or setting, based solely on the nominal current of the equipment. This initial approximation may be used to estimate the equipment grounding conductor size. However, since equipment operating and damage curves, protective device operating curves, and coordination with other devices are not considered in defining this value, the user is advised to verify and validate these settings before making the final selection of the equipment grounding conductor size. This validation is necessary because the values recommended by the software may be slightly below or above the appropriate value required to protect the equipment, allow proper operation, and coordinate with other system elements. In borderline cases, this difference may increase or decrease the grounding conductor size. Special attention should be given to Section 250.122b, which states that if the phase conductors are increased in size beyond that initially required by the ampacity tables, the area of the equipment grounding conductor should also be increased. This increase must be proportional to the increase in the area of the phase conductors. Accordingly, if the conductors selected due to voltage drop, short-circuit thermal stresses, or user-selected criteria differ from those selected solely by ampacity, the software calculates the area of the conductors from the final selection and divides this area by the original area of the conductor selected only by ampacity. The resulting ratio is multiplied by the area obtained from Table 250.122. The software then selects a conductor whose area is equal to or immediately greater than this product. It is important to clarify that conductor area refers to the conductor size multiplied by the number of conductors per phase. Within the same Section 250.122a, it is also clarified that equipment grounding conductors are not required to be larger than the conductor supplying the equipment. This condition is taken into account by the software when the result of this analysis indicates a grounding conductor larger than the phase conductors. In such cases, the final size of the equipment grounding conductor is defined as the size of the phase conductors. To view the equipment grounding conductor selected by the software, close this window using the OK button. Then complete the entry of the remaining circuit data and press the Calculate button. This will take you to the Results tab. There, you will find the grounding line indicating the selected conductor size and the number of equipment grounding conductors. In this same table, you can also see the phase conductor size selected based on ampacity, voltage drop, short circuit thermal stress, and the final conductor size selected for the circuit. If the phase conductor size selected by ampacity differs from the conductor shown in the final selection row, it can be anticipated that the equipment grounding conductor will be increased in the same proportion as the areas of the phase conductors. To determine the increase in the equipment grounding conductor area resulting from the increase in phase conductor size, the circuit calculation report may be opened. To do this, press the Accept button in the data entry window, select the corresponding circuit record in the data grid, and press the Calculation Report button. Within Section 6, titled Selection of the Nominal Size of the Equipment Grounding Conductor, the proportional increase in phase conductor areas and the final selected equipment grounding conductor can be verified, in compliance with Section 250.122(b). These are the basic steps for selecting the equipment grounding conductor in the Sizer Electric software. For detailed information, consult the user manual under the Help option or review the help files included in that same menu. Remember that you can always access online help by pressing the F1 function key on your keyboard. Thank you for your attention. We also recommend watching the complimentary videos on conductor selection, tray and raceway selection, and grounding grid design for a complete understanding of the Sizer Electric software.